Hey, hello everyone. This is Naveen here again after a long time. I know I was not active for quite some time, but it's good to be back and record this content. Actually, I have been missing this badly, but here I am back in action and let's get started. But before we jump into the actual content, right, I would like to say thank you to each and every one of you who are like constantly checking with me, like when I'm going to put when I'm going to continue this MongoDB administration series again. So whether this would be continued or not. So I was getting a lot of messages and emails from all the folks. So yes, definitely this is going to be continued, and today's video is on MongoDB only. Okay, so the last video on this series which I made was on indexes. That was very short, but today we are going to take a closer look again on the indexes. We are going to continue from where we left, and I'll be talking more on the single field and compound indexes today. So let's see what we have. Okay, the scenario what I'm going to give is, let's say I have a query, okay, which I'll be showing it to you in a while. So the query is at present taking 400 milliseconds. Okay, so we or you are going to help me in optimizing that query further. Like by the end of this session, you will be in a position to recommend what would be the better index for that given query, so that the query can run faster. Okay, so that's the idea of this session. So let's get started. Okay, so MongoDB indexes. So in general, be it in any database products or anywhere, indexes usually are helpful in reading the data faster, right? So it helps in sorting your data. So it arranges your data in a proper way so that you can read it easily when you want to pull some data. So just to give a simple example, okay, I have this data which is presented here. Okay, I just have like two fields, ID and text, and it's just some random number and text. Okay, so let's say if I had to create an index for this, just a smaller data, just for assumption or to give a better understanding for you. Let's say I'm creating an index on this ID column. Okay, let's assume like this is your collection. Okay, though I have just represented in a table, but just assume this is your collection, which where you have ID, a key value pair like ID is 55, and you have a text which is mapped with data 1, etc. So now if I create an index on ID field, so let's say our index creation syntax is going to look something like this. So again, this is something which we covered in the previous video, but I just want to go back and have some sort of a refresher. That's why I'm just talking about this again. So let's say like you are creating an index on ID field. So this is how the data will look like you after like sorting. So ID 1 indicates you're sorting the data in ascending format. So it is 30, 45, 50, and the data gets, arranged in this format. If I want to sort it in a descending manner, like I'll just add -1, which I'll show it to you maybe in the demo, but that's how you create it with create the index with ascending and descending. So now let me switch the screen to my server. Okay, so this is again, like I have installed Mongo on a EC2 machine, and let me quickly connect and show you like what I have. So let's say show DBs. So these are the databases I have. So I want to actually load a sample data set which I have. I took a sample database from this site which talks about like vehicle sales data. Okay, this is the data which we are going to use to learn more about indexes. So I just have a small shell script which is going to help in loading the data to our MongoDB, and once this data is loaded, I will just show a sample of how the data set looks. It's a brand new collection which we are creating and we are loading the data. Okay, so it's almost done. Okay, awesome. Now our data is loaded, and as you can see, so we have a data loaded with the DB name demo, and maybe let me zoom this a bit, and let's do this. You can see here. So let's connect to the Mongo. Okay, and let's do show DBs. Okay, so demo is the database which we are going to use. Let me switch over to demo, and let's do show collections. Okay, cars is the collection name which I have defined, and let me show you a sample data. So everything I'm going to type in front of you so that it's easy, you will also understand like how the syntax works, etc. So let's do it. I'm going to like write a simple query to find, and let's say I want to limit to 3 records, and let's pull this output. So I'm using pretty so that the output looks in a better format. Okay, db.cars find. Okay, I'm missing something. It's not a function. It's db.cars, and let's say find. Okay, there is a typo in limit, that's why the query got errored out. Okay, so this is the data which we have. Okay, it has what is the year, make, what is the make of the car, and model, what type of body it is, transmission type, state, what is the condition, odometer, color, interior. So these are different fields which we have, and if I have to do a overall count to see how many records we have, so it's roughly around like 558k, okay, or 5.5 lakhs. Roughly we have this much amount of documents. Okay, now if I have to show you like what indexes, whether do we have an indexes on this existing collection, let's do it. If we write db.cars.getIndexes, this is going to give us a list of indexes in this collection. So underscore id, we get this default index which gets created, so let's not worry about this now, which means like I can say like there is no index in this collection apart from the underscore id, which is a default index which gets created. And there is another function which you can use, stats, collection name dot stats. Okay, so it is, in our case it is db.cars.stats. So one thing, so this has whole bunch of different information. So let's look at something which is more relevant. So like for example, the average object size is 349. So just to show you like how this value is derived, so you have the size and count. So if you divide these two, that will give you the average size of the object, as you can see, right, 349.22. so that's what you see here. And other things you see, storage size, free storage size, whether it's a capped collection or not, etc. Now let's go to the bottom where you will see details about the index. Like whatever we have seen with get indexes, it is similar, but it tells you like how many indexes are there, etc. Okay, now what we are going to do is, okay, so let me go back to the sample data set, whatever we queried. Okay, so let's say right now the scenario is we don't have any index, and let's say I want to query, and for example, let's take, I'm going to write a query where I want to pull the list of cars which was sold in the year of 2014. Okay, let's pick that scenario. What I'm going to do is I'm going to like put a condition here where I want to pull cars from 2014. So though this might have huge number of records, we are not interested in pulling all the data though, but let's look at the execution plan. Okay, so we'll see like how it looks like, how much time roughly it is taking, those kind of numbers. Let's look at it. Execution stats. Okay, so now this is the important one which we want to focus on. Okay, so now we don't have any index. Okay, this is the total number of documents it has to scan, examine, and it has returned this much number of rows. If you look at the execution time, it took 320 milliseconds to pull this data. So let's copy this. Okay, I'm going to copy this output and let's keep it in a notepad just as a reference, and we'll copy this query as well. So I'll say, so here I'll say no indexes. Now what we are going to do is, as a refresher, okay, I'm going to create a index on the year column. Okay, let's create the index there. So how do you create an index? So this is how, like, let me just pull this up and create, sorry for the typo, index, and we would be defining here. So if I say 1, again it's an ascending. If I want to do it in the reverse descending order, I'll just say -1. Okay, that's the only difference. So let's go with this for now. And now we got our index created. So the idea is like what I told you is, if you have index, it's going to help in retrieving the data faster. Let's look at the same query again. Okay, let's look at the execution stats now, how it looks like. Okay, so whatever, if I've told a few minutes back, if that is true, ideally this query should run faster now. Let's look at the execution stats. So now you could see it, then the query just has to examine the docs only which is needed. Since we have an index, it was able to only query all the documents which is needed, and it has returned the output. So when you see these two are matching, whatever is examined and whatever is returned is matching, then the query is in a good shape. Like, let's go back to this one notepad and let's pull the same thing here. No, so now after index creation, let me put it like this. So you could see a drastic difference in the execution time, right? So this took 320 milliseconds. This is like just 120. Okay, though the number might be small, but in real time, if you real time data, you would be having in huge volume, right? So there, this would make a big difference. Okay, so far, like, it is good. Like, I have this sort of requirement and I am able to pull the data. Now let's modify this query. Okay, let us go back to the same sample query, and let's say now I want to add additional condition in my statement. Okay, for example, let's say I want to also look at the cars which was sold in 2014, and I also want to look at the interior. So I want to, let's say I want to look at the cars, number of cars which had the interior as maybe gray, or yeah, let's pick gray or black. So now what I'm going to do is I'm just going to modify this condition. So what we can do, let's put a comma and type interior, okay, on which we are going to filter, and the condition is, let's go for black. Okay, and yeah, this is the condition which we want to filter. So here we already have an index on this year field. We just added interior to it. To I want to look at the cars which had interior with black color. Now let's look at this execution stats again. Let's see how well this numbers look like, right? So now as you see, the very first thing, there is a difference, like whatever it has examined to whatever it has written, there is a difference in these two numbers. Okay, so now how this can be optimized further is the question. So let's copy this output again, and I'll keep it here, and let's also copy this query. So why I'm copying it in a notepad is it's easy for us to refer those numbers again, like to see the difference or what benefit we get after creating the index. Okay, so now like we know there is a single field index on this field here. So let's see what happens if I create another index just on the interior alone. Okay, so let me copy it. I'll just say tb dot cars dot create index, and let's see if this is going to help in making the query to run faster. Let's go and create this index. Okay, now I have index in year column, I mean year field as well, and in interior as well. Let's go back to the same query which we were trying to execute, and let's take a look at this. Okay, so nothing has really changed. In fact, I would say it has made things even worse, because let me put it here, without adding that extra index, let's say like when I executed this query, we just had an index in the year, but after adding the index on the interior field as well, now it took 150 milliseconds, which is bad. I'll also add the index definition here for again for our reference. Let's keep it so that you will know like what had happened, and let's keep this as well. Okay, now so this is where we have a concept called compound index. Okay, where you could have more than one field defined in your index statement, and MongoDB engine will get benefited out of it. Okay, so instead of like I creating a separate index on year and interior, what we are going to do is we are going to create a single index which will be combining both year and interior. So let's see how it's going to look like. We'll use the similar syntax. So all I have to do is I just have to add year also here and interior. Okay, so now this will create one more index. So let's see how many indexes we have here. Okay, so underscore id is the default one which we'll ignore, then year underscore 1 and interior underscore 1, year underscore 1, and this is the one which we just created. This is the compound index. Now let's go back to the same query. Okay, and let's see how this one is performing. Okay, so now you look at this numbers. Let me copy it again, and let me also copy this index which we have created, and this query is still going to be the same. Now if you see, like this query initially took 133 milliseconds. Again, now we have further optimized and brought it down to 85 milliseconds, right? So this numbers are reducing. Like when you have a proper index, definitely like MongoDB can run queries in much more optimal manner. So now let's say my requirement is again changing. Okay, we'll go back to the same this sample query which we used, right? Let's look at the data again. Now let's say I want to change this data. Let's say I want to add some more filters and see what is happening. Okay, for that let's say I will pick let's pick the body type as sedan. Okay, we'll add that filter also in our code. Then okay, let me just, what I will do is we'll do like this. Let me add it. So we are going to say body is equal to or a colon, which we want to filter for sedan, and let's run it. Let's see how many record it has. Okay, so it took 78 milliseconds, and again you see this difference. Whenever like whenever you see this difference, there is always room for improvement, right? So let's copy this again, and as you know, now there is a compound index which could be created. So what I will do is I'm going to create another compound index which is going to cover all the conditions whatever we have used here. Okay, so I'm going to create an index something like this. Let's go and create it. Again, I'll just go up and let's put it here. Okay, this is the third index, or I think this is the fifth one which we are creating. Okay, now let's run the same query, and the expectation is like it's going to like examine and return same amount of data, which means like this query is performing better now. Okay, if you look at the total docs examine and return, those two are same, and in fact now if you look at the execution time, it has come down to 42 milliseconds. Okay, but in real time, okay, you cannot have these many indexes, right? So you have to decide depending on your workload what would be a single index which will meet all the criteria. Okay, so let's say if I go and look at the indexes, we have n number of indexes, and what I will do is let's drop all the indexes and have just one indexes. We'll just have one index, and I'll just show you. So now we don't have any index. Let's go and create this index again, whatever we created at the last. Okay, so now if I run the same command, right, it's going to be the same which is expected, because that is the index which was being used. Okay, if you come down, you will see what index was being used, and this is the one. Okay, and it also tells you like what fields were added here, interior and body. So it has full bunch of other information which in later sessions we'll talk more about it. For now, let's just look at this and see how things can be optimized. Okay. So now we have only one index, which is, well, it's good now. Now let's say, okay, let me just pull this up. Let's say my requirement is changed. Okay, I don't want to filter based on year. Okay, and I just want to filter based on these two conditions. Okay, so interior and the body type of the car. So this is what I'm going to filter. So just pause the video for a minute and think whether MongoDB is going to use the index whatever we have created or not. Okay, so I'll go and execute it. Let's see what is happening here. Now if you see, it took 420 milliseconds and it has scanned all the documents in this collection, and then it returned about 89,000 documents. Okay, so which means this is not a, whatever index we have here is not an optimal index for this scenario. But still, you might be thinking, we already have an index which is also covering these interior and body, but why Mongo was not able to make use of the index, right? So in general, when it comes to this compound index, right, so whatever is the index prefix which you use, that field should be part of your query. Okay, so when I say index field, let's take this index statement. Okay, so here maybe let's do it like this. Here is the index prefix, the first field which you have in your index. Okay, so this is what I was saying as an index prefix, or the leftmost part in your statement. Okay, your query should have this condition, so that then only Mongo will be able to make use of your index. Let's say I have created this index something like this, and okay, we'll go and create it, no, so that you can actually visually see it. So let's go and create this index. Now if you see, my index prefix is with interior, okay, which is there in my statement, and rest all is okay, like it doesn't matter which order you give, but again we'll talk more on this order as well in a while. But for now, let's say I'm going to go and create this index, and now let's run the same command. No, let's see what happens now. Okay, now if you see, MongoDB was able to use the index whatever we created with this order: interior, body and year. Okay, so with this you could see the field which is defined in the leftmost, so that is very crucial when you define the index, is when you define in a compound index, like when you want to define multiple fields in a compound index, whatever field you choose on the left side is very important, because depending on that only Mongo is going to decide whether I'm going to use the index or not. Okay, so now that's why you see, like as soon as we have that index, now if you look at this execution stats, right, you see like from 420 milliseconds we came down to 176, and the total docs examined is equal to the number of records which is written, number of documents which is returned. Okay, and here let's say this is the index we have. Okay, maybe let's go back here. I'll drop, let's see what indexes are there. I want to drop one index. I'll again modify the query, which will give you a better indexes. Sorry. Okay, so what we will do is we will remove this index. Okay, so let me copy this and we'll delete this index. So it is drop index, and let's put it here. Okay, now this index is dropped. We have two index only. So year 1, interior, and body 1. We have index on these three fields. Now let's say I want to change, I want to query something like this. Okay, let me go back and I'll take this or we'll do like this. So now again question, so just pause the video and think if Mongo would be using the index whatever we have created. So this is the index we currently have. Maybe let me just copy it and I'll put it here. Just think for a while and see whether this query could be able to make use of this index or not. I'll go and run it now. Let's see what is happening. Okay, so if you see, total dogs examined is 30231 and returned is 30231, which means if you come down, it was able to make use of this index, and here also you could see it did an index scan and it went through fine. The reason is, let me go back here. So year is the first one which we have in our index, so it will expect year here in our statement. So in the statement it can be anywhere, so I can also do like body type comma, like this also we can do, which is still okay. But in index, when you create the index, at that time you have to be careful like what is going to be the first key. Again, there is a separate rule which you have to follow when you create this sort of indexes. Okay, so there is something called there are like few conditions which you have to meet when you create this compound index, or few guidelines I would say. Okay, we have something called ESR, which is let me just type it here, ESR. Okay, so E is nothing but equality, and S is for sort, and R is for range. So equality is nothing but, let's say you are querying something like this. So this is like a equality search where in your Mongo query you are doing something like this, or ID is equal to some number you are searching. All these are like equality condition. So whatever is there in the equality condition in your query, that should be on the leftmost side in your index creation statement. Okay, equality. Then comes the sorting key, on what field you are going to sort. So let's say you have a price column or something and you want to sort on this price. So this would be the next field which you will add in your index. And range is something, let's say you want to pull based on date greater than some year. Okay, so in that case this sort of range sort of syntax field will be on the third place. Okay, or this would be the format which you have to follow. So now again a question to you. So based on this, right, so equality, sort and range, so this ESR logic, with this only you are going to decide how your index is going to be placed, like on what order the fields or the keys whatever you use in the index is going to be placed. You will be deciding. Now let's say I'm going to let's go back to this same data. No, we will just look at the sample data, and I'll just say limit 1 and 30. Okay, this is the sample data which we have. Now I'm going to write a query. Okay, and before that I'll drop all the indexes. So we don't have any index apart from the default _1. Okay, now what I'm going to do is, let's say this is the requirement I have. Let me just zoom in a bit and let's query this. So my requirement is, I'm going to let's say I'm going to filter again based on year. Okay, and we'll pick 2013 for example, and then we also have selling price. Okay, let's say I want to filter let based on the selling price. Excuse me. I'll say selling price greater than maybe 25,000. Okay, and then I want to sort this data. So what I will do is, maybe I can sort this data based on odometer. Okay, odometer is nothing but, like in cars, it's going to tell you how much kilometer the car has traveled. So let's pick that. Let's say I want to sort based on this. Now if I run this query, okay, let's run it, we'll see whether okay is okay. We haven't defined the sort order. Let's do it like this. Okay, before even I do it right, I'll just copy this query and I'll put it in a notepad, so you will get better visibility like what it is. So this is the query I have. Okay, no indexes, but this is the query which my application is going to run, this format of query, or this is the workload which I'll be getting. Okay, I'll be searching either based on some year and selling price with some range greater than something, and I'll filter based on this odometer. Okay, just again, like, think about this ESR rule which I told. Equality will be on the leftmost, then would be your sort, then the range. Okay, now if I run this code, let's do explain, and we'll look at the execution stats. Execution stats. Okay, I think let's go up. Okay, so this is the number we have got. Okay, and if you look at this, total docs examined this, which means it went for whole collection scan and return this much number of rows. We have about 15,000 documents which is matching this condition. Now if you look at the execution time, it is 398 milliseconds. Now we have to define an index which is going to make this query to run faster. Okay, and we are going to use this logic. So what we can do is, we'll say cars, and you can say create index, and now equality is the very first one. So in my query, obviously I'm using a year, filtering based on year. So I'll go with this one, 2023, sorry, 2013. Oh my bad. Okay, this is an index. Okay, I just have to define the sort order. Next, so in my query, I have selling price which falls under the range category, and sort is based on odometer. So let me put this here, and at last this is going to be the range. Now I'll go and, okay, there is a typo, let me just correct it. So this is going to be the index which we have to create based on this logic, whatever we just discussed. Let's go and create it, and I'm going to run this. Okay, now see the difference, the index whatever we have created, right? So look at the huge difference. This was taking close to 400 milliseconds, we brought it down to 146 milliseconds. And if you look at the total docs examine, 154434, and that's the number of doc which it has returned back. So this is how you can create a better index for your workload. Okay, now I have another question. Okay, so though whatever we have seen here, this is giving a better output. Okay, what I'm going to do is I'm going to change this index format a little bit. Okay, I'm going to remove this odometer and I'll put it here. So it's like selling price and then odometer. Okay, let's copy this and let's create this index. Okay, so now what I'm going to do is I'm going to change this query as well. Just watch carefully. This is the index we have. So we have two indexes. Maybe I'll keep it like this. Okay, now okay, wait, oh, that's fine. So I'll keep it like this. So we have, I'll just name this as index 1 just for an example, and I'll name this as index 2. Okay, so now the question is, let's remove this one. Okay, let's remove this sort. So now we don't, or let me, I'm just thinking which one would be a better. Okay, let's do it like this. So now I have a query like this. Okay, it is filtering based on year and then I'm sorting it based on odometer. Okay, now if I run this query, so between these two indexes, which index you think it's going to use? So just think about it and put your answers in the comment section. Let's see what answer you guys get it, and yeah, let's see. I'm also curious to know what index it's going to choose. I'll wait for your response. You can put your answers in the comment section. Okay, so that's all I had for this video. I hope you learned something new and you like the content. Please do share your feedback. That really helps me in making better content. And thanks everyone. Bye.